Hi guys, we are going to start semester 2 with chapter 7, section 3. And today what we're going to be going over is formula mass and molar mass. So by the end of the period, you should be able to know how to add up the formula mass and the molar mass of any chemical formula. Remember, a chemical formula is just a way of writing what elements are in a compound and how many of each atom are in that compound. For example, down here, this is water's chemical formula, H2O, and it's telling us that you have 2 hydrogen atoms for every 1 oxygen atom. So we know what elements are in there, hydrogen and oxygen, and how many of each one we have, 2 hydrogens and 1 oxygen. So that's a chemical formula. The mass of the formula is going to be the sum you're adding of the average atomic masses. And remember that the atomic masses are found on the periodic table. It's the number with the decimal place, usually at the bottom of the symbol. Okay, so for example, if I were to look up hydrogen, it might say 1.01, or some are more specific and they might say 1.008. We are going to use the 2 decimal places. We're going to use the hundredths place, but you wouldn't get it wrong if you used the other version. Okay, so depending on what periodic table you look at, you might get a different value, and hydrogen is element 1 because it has 1 proton in there. Okay, so it's going to be the sum of the average atomic masses of all the elements represented in a formula. So all we are going to do is we're going to add up the masses. Masses. Easy peasy. We're just going to add them up. Let's start actually with water because we know its formula and it's very simple. So we have 2 hydrogens and 1 oxygen. Remember, it has a Lewis structure that looks like this. Okay, it's a bent shape. So if I were to draw it, kind of looks like this. The 2 little hydrogens are like the ears on the oxygen. And the mass of this little molecule is the oxygen plus the 2 hydrogens. So the hydrogens each have a mass, when you look up on the periodic table, of 1.01. And there are 2 of them. So the total for hydrogen is actually 2.02. Okay, because we have 2 of them. And there's only 1 oxygen, so it's just 16.00. The total mass of the whole molecule is the sum. We're going to add them up and get 18.02. Easy peasy. That's it. Okay, that's what we're doing today. So HCl, we're kind of going in reverse order here. Sorry. Also easy, 1.01 AMU from the hydrogen. And if we look up chlorine on the periodic table, its atomic mass is 35.45 AMU. So the sum, the mass of this little molecule of HCl is going to be 36.46 atomic mass units. That's what AMU stands for. Okay, let's do one that's a little harder. Let's do KClO3. K is potassium, Cl is chlorine with 3 oxygens around it. Do you remember what ClO3 is? It's chlorate. Is that what you said? This is potassium chlorate. And the mass of potassium chlorate is, potassium is 39.10, and I only have 1 of them, so it doesn't change. Multiplying it by 1 does not change the number. There's 1 chlorine, 35.45. And there are 3 oxygens. So now I have to multiply that 16, which is the mass of oxygen found on the periodic table, times 3, and I will get 48.00. Okay, and we're going to add them all up. We're going to do the sum. So if I add up 48, 35.45, and 39.10, I get 122.55. Okay, as the mass of the whole thing, KClO3. So the 3 here, just to be clear, comes from the little subscript 3 up above. So that 3 means you have 3 oxygens, and the mass of oxygen has to be multiplied by 3. I want you guys to try the practice problems on page 238, and we will go over those when I see you in class tomorrow. So give these a try. Okay, just do your best, add up the masses, and we'll go over tomorrow what we get. The second part, here's the trick, we're not learning anything different. The molar mass is the mass of 1 mole. Okay, that makes sense, right? The mass of 1 mole of something. So a mole is a huge number of atoms. The mass of that huge number is called the molar mass. And if you have a mole, remember it's always this number, that's why it's highlighted, 6.022 times 10 to the 23rd. A mole of anything is that number. So let's say you have a mole of grapes. That means you have this many grapes. The molar mass would be how much do those grapes weigh? That would be a lot of grapes. That would be very heavy. If they were bowling balls and I had a mole of bowling balls, that's going to weigh a whole lot more than the grapes even did. So the mass of 1 mole of atoms depends on the size of the atom. Tiny atoms like hydrogen will have a smaller molar mass. It has a molar mass of 1. A bigger atom like, pick a really big one, uranium, has a mass of 235 to 238. It's much, much bigger. So it's going to have a bigger molar mass. How do I find the molar mass of a compound? It's the exact same thing that we just did. So there's nothing different. The formula mass is the mass of a single atom or molecule, like water. We were finding the mass of 1 water molecule. That's not very useful because when do you ever use 1 water molecule? Never. Okay, what we're going to use is a whole bunch of them. So what's more useful is not atomic mass units, but grams, because in the lab we can measure out a certain number of grams of water, like 10 grams, for example, or 20 grams, or 18 grams of water. So what we want is the molar mass. To find the molar mass, it's the exact same process. The only thing different are the units. So if I were to come up here for water, we found, this is the formula mass of water. The molar mass is the exact same number, 18.02, but now instead of atomic mass units, that's how many grams there are per, that's what this means, per 1 mole of water. So 1 mole of water, another way of writing this fraction here, is 1 mole of water. I'll put a little H2O down here, subscript. 1 mole of water equals 18.02 grams. So if I want to use a mole of water in my lab, I can just measure out 18.02 grams on my balance, and then I know I have a mole of water. Okay, and so numerically, I just add up the hydrogens and the oxygen exactly like I did, and I will get the exact same number. But now it's in grams. So down here, sample problem G, barium nitrate, that's BaNO3, in parentheses, this is trying to trick us, and a 2 outside the parentheses. What does that mean? That means I have NO3, remember it looks like this, and it's negatively charged. And I have 2 of them, so I would have to draw another one. And I'm being lazy and leaving off some of these guys. Let's put all the dots. Here's the correct Lewis structure. And I need 2 of them. Whoops. There we go. So I have 2 nitrates and 1 barium, Ba2+, because it's an alkaline earth metal. It's in group 2, so it's going to have a 2+ charge. So what's the mass of this whole thing, this whole lump of molecules? This isn't really how they're arranged, but I don't want to confuse you too much. So there are 2 nitrogens. This 2 outside, kind of like in math, it's distributed. So the 2 applies to the nitrogen. There are 2 of them. And the 2 applies to the 3 oxygen. So you're multiplying 2 and 3 to get 6 because there are, let me point to them in yellow, 1, 2, 3, 4, 5, 6 oxygens in 2 nitrate molecules. So we have 6 oxygens, 2 nitrogens, and 1 barium. I would have to look up my mass of barium, and I'm going to need to pull up my periodic table for that. Periodic table. Barium's in group 2. It has a mass of 137.33. That's pretty heavy. 137.33 grams. And the 2 nitrogens, nitrogen is 14.01 grams per mole. It's a G. Oxygen is 16, and there are 6 of them. So 6 times 16 grams. And then we would have to multiply them out. 137.33 plus 28.02. And I believe that is 90, is it 92 or 96? 16 times 6, 96 grams. It's 0.00. And then we add all of these up and we should get our grand total of 261.35. Okay, calcium chlorate. Go ahead and try adding up the molar mass of calcium chlorate. If you just Google the answer or use my answers, you're not going to learn as much. So look them up, add them up just like we did barium nitrate. See if you get the correct answer. Okay, see if you can get that answer of 206.98. And if you can't, make sure you come with questions tomorrow. Also, I would like you to look at the practice problems on page 239 of your textbook. Okay, and we will go over these practice problems at the beginning of class tomorrow. I hope you guys have a wonderful day, and I'm looking forward to seeing you guys tomorrow. Bye-bye.